Hi guys, welcome to my channel. Today we'll be solving the May 15th challenge. Let's get into the question. The question is deepest level sum. To explain that, given a binary tree, we have to find the deepest level and we have to find what is the sum of the deepest level. So what will be the deepest level here? So this is the deepest level, 7. And in the same level we also have 8 value, so we have to return 7 plus 8. What is the sum of that? That is 15. So let's take a example, take this as an example, and let's see how we can solve this. So this since we have to traverse in a level, we can either use BFS or DFS. Today I'll be explaining the DFS solution. So so the solution goes like this. For keeping track of the depth sum, we will maintain a hash map to keep the key as the depth and the value as the sum. So initially hash map is empty, and when we start traversing the node in DFS, first we will pass root as the parameter to the DFS function, and also we will be passing one more parameter, which is the depth. Okay, that will be 0. We will pass it as 0 at the first time. When we get into the function, we will check whether we have this depth in our map or not. If we does not have that key, then we will insert that key and we will add the value as whatever this value is, current value. So right now our hash map has a key 0 and the value 1. Now we will call recursively to its left and right. Now when we call the left child, we will increment this value with 1 and we will call it. So the depth is 1 here. Then we will see whether 1 is existing in our hash map. There is no 1. Then we will insert 1 key in our hash map, and we will along with that we will put the value as this node value. Now we will recursively call it this left child. So here while we are calling, we will call it with the depth 2, 2 which is 1 plus 1 plus 1 is 2. So now again same thing, we will add this key if it is not existing, and we will add the value as 4 in our hash map. Similarly, we will call the left child of this node with along with the depth 2 plus 1, that is 3. This is also not present in our hash map, so we will add its key and we will insert the value as 7. Now this does not have any more childs, so the null will return back and the null will return back in the left and right. Now this will backtrack to this one, and this will check whether this has a right child. This is also null, it will return back. Now this will backtrack here, and this will check its right child. We have a right child. While we are calling from here to this one, we will call with the depth whatever the parent's depth plus 1. So this will be called with the depth as 2. Since we already have our 2 in our hash map, we will just add this value to the already existing value. So we will add 5 to the depth 2. Okay, now again this will backtrack. Since it does not have a left and right child, the nulls will return back, and we will backtrack like this, and this also finished with both left and child. This will backtrack here. Now this will continue with its right child. While it is calling, it will call with its parent's depth plus 1, which is the depth is 1 for this. Now this 1 depth is already in our hash map, so we will add this value to our hash map with 1 key, so that is 3. And we will this will call its left child is not there, it will return back, and it will call the right child with the depth 1 plus 1, that is 2, and 2 is already in our hash map. We will add this value to the 2 key, so we will add this value to this one. And again this root this node will try to call its left. There's no left, it will return back, and it will try to call its right. There is right. When it is calling, it will call with the depth 2 plus 1, that is 3, and we will be adding this value to our hash map. After finishing all the iterations, this will return back, then this will return back to the caller. After doing all this, our hash map will be fully populated with the level sum. So we have to find out which is the greatest key, and we will be returning the sum of this. So in our case, this will be returned as our value. So this is 7 plus 8 is nothing but 15. 15 will be our output. So let's see how we will implement it in Python. So for doing this, first as I was telling you, we need a hash map. So let me take a hash map. In Python we will take map. Okay, and we need not worry about which is the max, right? So we will keep track of the max depth in one variable. Initially we will keep it as -1. So then finally what we will do, we will return maps value of key. Once we populate all this map, we will return this max depth value in the map. Only if we have a max depth, if this is not equal to -1, else we will return 0. So if we find a max depth, then we will return the max depth value, or else we will return true. So let's see how we will populate this max depth. For that we will write a DFS function which will take two parameters. One is the root, current root, and one more is the depth. Okay, now if the root is null, then we will simply return back, we will not do anything, or else we will if the depth is greater than the max depth, that means we still don't have this key in our hash map, then we will update this max depth and we will add the key for that. We will add the key for that in the hash map. M of depth is equal to, we will just initialize the value with 0. Then here we can update our value with the current roots value. Plus is equal to current roots value. Okay, this way our each depth will be added with the current depth's root value. Then next step, we will be calling left and right of the roots with depth plus 1. Let's call the left and right. Okay, this is the code, pretty much the code, I think. Now in our main function, this is the internal function. In our main function, we will call the DFS function to populate this map. We will call it with our given root and the initial depth as 0. So let's try to run this to see whether we have any bugs. Local variable, so m is not visible inside this function, so we will include it. Now it will be visible inside. So let's try to run it. Okay, seems to work fine. I will try to submit it now. The code got submitted. Thanks for watching. See you in the next video.